In this video, we'll be discussing some of the techniques that you'll be learning in Project 1 and also the calibration of glassware. So in the Analytical Measurement Lab, your goal is to learn the techniques and skills needed to perform precise and accurate measurements. In order to do that, you need to familiarize yourself with some of the materials, and then also you will need to calibrate your glassware. So some of the analytical techniques you will start out kind of practicing with is weighing, and you've probably used a balance before in lab, but you might not have used our analytical balances. And so these go to 4 decimal places. And so they can accurately weigh a very small amount of material. And by knowing your weight to this many digits is that we can have good confidence, we can know masses and then therefore concentrations of solutions to potentially 4 significant figures. And if we want to be accurate, having the most digits might be the best way to achieve that. So you'll be practicing weighing, and again, the point is just, can you weigh and not have any movement in this last digit here? And so you'll practice weighing some sand. Then you'll also get some practice with the glassware that we'll be using. So again, where do you weigh? Do you weigh in weigh paper, or do you weigh right into a beaker and then put your solvent right in there to make sure that you're getting every last little grain of sand in there? So quantitatively transfer, again, just making sure all of the mass that you weighed out ends up in your solution. Then you'll get some practice with the 10 ml pipette that you will be calibrating. And so taking an aliquot, you may not have all have used a manual pipette before, but we'll have a very thin tube. And it's set to dispense exactly 10 milliliters. And we'll talk a little bit more about that. And then likewise also the rinsing effectiveness. And so you'll see with some colored water, as you're transferring liquid, if any of it is staying behind, and how that could potentially affect your measurements. So in the second part of the lab, you'll be calibrating glassware that you'll be using throughout the lab. And in particular, the 10 ml pipette and your 50 ml burette will come in Project 2 when you're running titrations. And so there's different types of volumetric glassware. There's those that dispense a certain volume. And so in particular, the pipette here dispenses a set volume. We also have volumetric glassware like the volumetric flask, which contains a certain volume. And so again, if it's filled up to the line, it will contain exactly this amount. And then again, the burette here is something that we will have that will dispense. But we'll see the burette's a little different since it has a graduated amount. We can dispense ranges of volumes within that 50 mils, whereas this pipette will only deliver that 10 mil. Volumetric glassware is made to either dispense or contain. When it's made, the glass is blown at a specific temperature, and so this 10 mil pipette is calibrated at 20 degrees Celsius. And so to account for any fluctuations in the lab, so if the lab is maybe a little cooler or a little warmer, the amount that that pipette will dispense might change a little bit. And then likewise, you might have slight imperfections in the glass. And so the calibration of glassware is really to account for any systemic error in our glassware. And so for the pipette and the volumetric flask, you will be doing this by weighing the amount of water that is in either the pipette or the flask. So you will and you will do several trials of these. And so you'll be able to get a standard deviation and also a 95% confidence interval. And so by taking an aliquot of water and then dispensing that and weighing it using the density, we can then figure out what is the actual volume that's being dispensed. And so you might find out that your 10 ml pipette actually dispenses 10.02 milliliters. And so this will be important to know for when you're using in your calculations how exactly, how many, with 4 significant figures accuracy, how much that pipette dispenses. Likewise, you might figure out that your volumetric flask contains 24.98 milliliters. And that's completely fine, there's nothing wrong with the glassware, but now that we know when we calibrate, so when I'm making a solution and I'm plugging in my volumes for my concentration, or I'm using the volume to calculate moles, I know with 4 significant figures the volume. The burette's going to be a little bit different since that dispenses over a range, and the burette is since it's a small long tube, you can have slight imperfections going throughout the tube. So if you think of your burette here, you might have just like slight imperfections that we couldn't necessarily see, but then throughout the tube, you are getting slightly different volumes. So, and I'm gonna add here, you will also be getting an error analysis, and so knowing exactly what range you might be getting as well. For the burette, the error will look a little different, that you will have a correction graph over the range of the 50 ml pipette here. And so you might end up having a graph that looks a little goofy, but that's completely fine. So I'm just going to populate these here. So I just want you to show your graph might be a straight line, it might not be a straight line. Whatever it is, that is what your burette is calibrated at. And so if you end up with a graph like this, what that's showing me is that for a correction volume, between the, in the first 10 milliliters that I've dispensed, I actually didn't dispense 10 milliliters, I dispensed 10.01 milliliters. And again, that's going to be important later on when I'm doing my calculations, because I want to know to as many significant digits, and if I can know to this fourth, the second decimal place, I can get 4 significant digits on there. But we can see that my burette is a little different, so when I go from 20 to 30, I actually don't dispense exactly 10 there, I'm actually doing slightly less than 10 milliliters. And so I can correct for that volume. And so keeping in mind that the calibrations that you do today, you can use throughout, particularly in project 2, and then likewise your final project when you use these pieces of glassware again.